Hi, and thanks for stopping in again. I recently finished my tube vise here. So this was based on a vise built by Jason from Fireball Tool. I've got some links in the description for the videos on this build if you want to have a look at it. And I mean, the vise functions perfectly. I haven't actually bolted it down to the table yet, and that's the reason for this video actually, but you know, in terms of swiveling around, it just works perfect, and you can lock those back up, so there's no issues with that. But I'm sort of a little bit lateral to just working in the corner here on one plane. So what I wanted to do was build a device to tip the vise up so that it can come up this way, and then I can rotate it on this plane like this. Now Jason built a tilting base type thing for his vise, and he has got a video for that, and this build will be sort of based around that build. So I'll put a link in the description for Jason's video as well. So there are three main parts to this tilting bracket. One is, I don't know what they call this, the anchor maybe. And in Jason's case, you know, his one was a little bit of a different shape. This might be made a bit smaller as well. But it basically gets welded to the bench. And in this case, I'll have to put it in there and just weld along the top here, and maybe at the back and down the leg here a little bit. And that needs to be a sturdy piece of steel because the tilting frame hinges on here, and all the weights on this frame, on this piece. The second piece is the swivel bit, so it pivots on this point here, and then you know, you can sort of set whatever angle you want for that. And that gets bolted here. So the pivot point comes up through here, and then the anchoring point is here. And then when you want to, let me just turn this way, lift the vise up, you would loosen off these screws and the vise would come up like that. So now the vise is here. And the last part is where the vise actually bolts onto, and that gets welded on there. So remember, this is all going to be pretty much sitting on the table. This is going to be underneath, welded in there, and the pivot piece will be in there like that. So it's quite a simple sort of setup, so it should be a fun build, this one. I've got the plates cut out here. This is the pivot plate. So this is the one where it will have a hole in here, and it will go onto that fixture there, and then pivot up like that. So it needs a slot in here, and the way I'm going to do that is in the mill. So what I'll do is I'll put a center drill down here just to make a bit of a mark in there, or a bit of a taper, and then I can put this in the rotating table and I just center the spindle up with this center drill that I've drilled in here, and that gets me a pivot point here on the rotary table as well. And then I'll be able to bring the table offset and then just scribe an arc here with an end mill until I get right through. Now I did notice in Jason's one he had the locking screw positions were here and 90 degrees up here as well. And I read a few of his people who had put comments on his video, and some of them were saying you maybe should have had a 45 and maybe in between 45 as well. So I mean, it's something I can easily do in the rotary table, so I might just add those in as well. That's just a matter of drilling slightly bigger holes in these positions here, for the bolt to bolt into there and lock it into position. And this plate here it's basically not much needs to be done to it, just needs squaring up on this side. And basically, I mean, I've just rough drawn this, but basically the vise sits on here and it bolts in these positions here. Now the problem is this is only 10mm steel plate, which is about 3/8, so you haven't got a lot of threads there. And what I might do in this situation is I might drill and tap the holes here as normal, but then I might put a stud in there or a bolt in there so it's come up, and then I can put the vise on top and just put a nut on the top, and I can then weld the bolt from the other side, and that should be plenty strong enough. It shouldn't come out. So I think the next step will be to make this pivot plate up in the mill. You saw me on the belt grinder, I was just making this corner here square. Didn't really worry too much about these ones here because this is going to get chopped out anyway. So as long as it's square here, then we should be right. Here we are set up in the lathe. So I've got the rotary table that was centered on the spindle, and then I have the center drill hole in the plate here, and I've centered that on the spindle as well. And then I've moved the table down this way. I think it's 165mm, and this is where we will start our first hole. And these are the I guess indexing holes. So when the vise is flat on the bench, it's in one of these holes, and when it's up 90 degrees it'll be in a hole over here, and maybe we'll have a 45 degree and maybe some in between there as well, just to give some options. I don't really know if that's necessary or not, but the way it clamps up, like if you've seen on Jason's video where he talks about a shoulder bolt, I think that's quite a good way to do it. So if that's the case, then you're going to need these holes in here if you do want to get these other angles at a later time. So it's not much more work now to just drill an extra 3 holes here, and then if we use them, we use them, and if we don't use them, well, there's no problem. They just sit there doing nothing. So basically I drill the hole here, and then I turn the rotary table around to these degrees to drill the other holes. And then once I get these holes drilled, these will be probably about 20mm holes. And then once they've been drilled, then I'll put an M-mill in here, and I'll just go around the full 90 here until I get through. So I've got the pivot plate done, as you saw. So there are 5 positions here, and this is where the bolt will go in to mount it, you know, the shoulder bolt. I've overhung the top plate by about 10 millimeters, about 3/8 of an inch, and that's so I can weld. I've got a little bit of a ledge or corner under here that I can weld or tack it up so I can actually pull it all apart and put it on the bench and weld it. And you just saw me sort of marking out around the perimeter on the other side of the swivel base here. Now this side here will be all sort of square with the corner, but the other side will be the shape of the swivel base. So the next step is I'm going to unbolt this vise and cut that top plate here out along the other side there and shape it up to the same shape as the swivel base here. Then I need to work on a pin that comes out of the solid bar here, and there will be a nut that goes on here, and then there will be a hole drilled and tapped in the solid bar behind here, and that will be a bolt that fits in there. The mounting plate on the top here came out pretty good with the shaping on the other side of the vise there. On this side I just wanted to keep it all square in the front and on the side, and that leaves me a little area in here where I can weld to as well. So the vise bolts on there well, lines up in position very good. So I think the next step here is to weld this plate here with the slot in it to this base plate. And what I'll do is I'll just make sure it's all lined up, and then I'll just put a couple of tacks in here and then maybe take it all off and weld it separately on the bench there. Once that is complete, the next step after that would be to work on this pin that's going to come through. So this is the pivoting pin. It'll be welded or screwed into this big square stock on the front, and then there'll be a hole that comes through here, and I think this will be another 18 millimeter hole maybe. I just wanted to make it a little bit bigger than just, you know, a small hole, just so that there's more, I guess, bearing surface for it to, you know, rotate on. The bigger the hole, probably the more stable it is and stops it going all wobbly. You've just seen a few parts being made up there. So I've made up a bolt. So the bolt goes into the hole at the back here, into your indexing holes, and it is a shoulder bolt. So it's got that step on it there. And I also made up the nut that goes onto this side here. Now the third piece I made was this pivot pin, and as you saw, I pressed it into the big square block here, but it was pretty tight, and I probably got this a little bit wrong because it ended up being very tight. And as you saw, I tried to press it in, and there's actually still a gap in here. It's about a 1.5 millimeter gap, or 1/16 of an inch. I just couldn't press it in any further. In fact, I even, started bending the bottom bracket on my press when I was trying to press this in. So I thought I'd just stop there. So what that means is this bearing surface sticks out now, about 1.5 millimeters. So what I had to do was, for the nut, I had to cut it in, put a recess in here about probably just over 1.5 millimeters, so that when that screws on, it actually goes over the bearing area there. So that sort of fixed the problem. That's okay. I don't think that's going to be much of an issue there. So I welded it on to the table here, and then some welds down the back and down the front here as well. It's pretty solid in place. That's not going to move. Let me get all this together and we'll see how it works. So it actually functions pretty good. It's not quite finished yet, so I do need to just clean it up and paint it. And the other thing I need to do is make up some handles, so drill some holes through these bolt and nut here, and put in a slidable handle. I'm just doing those by hand at the moment, and depending where the weight is on the vise, it's kind of hard to tighten up.